Okay, so welcome back and let's discuss about the disturbances in the atmosphere. As I told you about the precipitation type, now we'll look at the atmospheric disturbances where the topic today will be, first topic is cyclone. Cyclone. Okay. So what is cyclone? So as some of you have asked me what is temperate cyclone, so many things I got a question. Temperate cyclone rainfall caused due to nimbostratus cloud. Yes, nimbostratus is one among the cloud here. So we will have this. We will have this in detail now about the cyclone. What is the cyclone? Can anyone tell me? Cyclone is nothing but the intense low pressure condition associated with very high velocity whirlwind. Okay, I said intense low pressure conditions associated with very high velocity whirlwind, associated with very high velocity whirlwind. Intense low pressure conditions associated with very high velocity whirlwind. I mean twisting wind. Whirlwind in spiraling wind. The wind which is rising up, but it is moving in this way. Whirling of the wind is there. Okay. So these are very intense low pressure conditions. I told you earlier, low pressure conditions mean the isobar in this case. If it is a low pressure condition, see here, the isobar are closely spaced. Just the isobar here. Let us say it is 800 millibar, 780 millibar, 760 millibar, 740 millibar, 720 millibar, like this. Pressure is there. So it is a high pressure condition here. But intense low pressure condition mean if it is 800, you will have 820, 840, 860, 880 millibar. Okay. So it is the lowest pressure at the center. In this case, lowest pressure at the center you have. So it is low pressure condition. In this low pressure conditions, if these are low pressure conditions, lowest pressure is here on the above part. If you will see, ऊपरी वाला हिस्सा को अगर हम देखेंगे तो ऐसे होंगे ये, and the wind here is whirling like this. Okay, this is a cyclone. Tropical cyclone can be, it is like, in this way, very intense low pressure condition. I said very intense low pressure condition associated with whirling of the wind. Here the air will try to converge in this case from the periphery region. Air will come in this way, isn't it? Periphery से ऐसे आएगा, हवा तो ऐसे आएगी, आके यहाँ पे, because it will come in this way, it will converge. Convergence of this takes place, and subsequently there is rise in the air parcel, rise in the air parcel here, rise in the air parcel you will have here, right? So this type of conditions where throwing of the air takes place like this. See here, in case of a cyclone, convergence of the air and whirling of the air and moving upward. ये जो आपको येलो में दिखाया, these are isobar. These are the isobar. Vertically, these are isobar. Here you have the lowest pressure, I said. Here you have the lowest pressure, lowest one, and the air is converging from all sides and going up subsequently. Air is converging from all sides and going up subsequently. Whirling of the air is here, मतलब ये whirl कर रहा है, that's why it has a this type of movement, circular movement, and it is moving up. Circular movement with vertical rise in the air parcel you have. Circular movement with vertical rise. Because you imagine a case, I am here in the low pressure condition. All air coming from the nearby surrounding area, it is converging here. It is converging, and because of Coriolis force, twisting of the air takes place. You know it. Twisting of the air takes place. That's why it will have like whirling. It whirls and it move upward. ये चारों तरफ से हवा आके यहाँ converge करेगा. Because of the convergence here, they will try now. Because of the Coriolis force, the wind will divert from its normal path towards right in the northern hemisphere, left in southern hemisphere. So ये घूमेगा ऐसे, ये घूमते हुए ऊपर उठेगा ये. It will converge, it will divert its direction, whirling of this takes place and move vertically upward. This type of condition is a cyclonic condition here. Here you can see this condition takes place in this case, and the whirling of the air, here it is, the area is increasing in the upper part because the velocity, the what you call the pressure in that region is very less. Pressure is less here because of the low pressure condition. Vertical rise in the air, convergence of the air, and vertical it is rising up. It is going upward. This vertical rise in the air leads to even cloud formation subsequently, and also the rainfall. So here it forms cloud. Cloud formation will be here in this case also, and cloud will be here itself. Cloud formation takes place at the margin of this cyclone also. So let us see what are the condition for the development of the cyclone, and so many things are there, related features. I just tried to define you what is a cyclone, and intense low pressure conditions associated with very high velocity whirlwind. This is called as a cyclone. I think this definition is clear to you all. Now, if this is a cyclone, what are the conditions? What are the conditions for the development of a cyclone, or what are the major types of cyclone? So, first point is there are two types of cyclone. Two types of cyclones. One, tropical cyclone. Tropical cyclone. It is found, develops in the tropical region, in the tropical region between 5 degree to 30 degree latitudes. Why I have written 5 degree? Why I have written 5 degree latitude? 5 to 30 degree latitude, I said usually the tropical cyclone develops between 5 degree to 30 degree latitudes. Why they develop in this particular regions? Because Coriolis force is necessary within 0 to 5 degree latitude. There is no Coriolis effect. Coriolis effect is very less, very less, which doesn't have the capacity to whirl the wind. इतना लो कोरियलिस फोर्स होता है कि इसको वो ट्विस्ट नहीं कर पाता है. We will discuss about this movement and all. We will discuss, my dear. आपको direction, movement सब कुछ बताएंगे. Don't worry. Let the concept be first. You should have that concept first. Okay. We will discuss the direction of the movement, how they move, why they move, what the associated condition, everything we will discuss. Cyclone. Some of you must have experienced this cyclone. Why the cyclone develop over the tropical seas or water bodies? What are the characteristics, what are the structure, how they move, what are the weather condition, everything we will discuss. Don't worry on that. And one more thing I would like to say, I was just looking at the image, I didn't able to sync. So tomorrow I will definitely show you all the images of your clouds also. Okay, clouds images and all other things also we will see. Tropical cyclone develops in the tropical region between 5 degree to 30 degree latitudes, generally between 5 to 30 degree latitudes. Why? Why not? Why will not find between near the equator? Because at the equator Coriolis force is very low, almost 0. So at the equator there is no twisting of the air. So convectional instability will be there. No whirling of the wind. Whirling of wind नहीं होगा. हवा जो ना घूमेगा नहीं, ऊपर सीधे जाएंगे. तो एक convectional instability हुआ. So there should be like whirl of wind is very important. That is not possible because of there is absence of Coriolis force in that region. Okay. Second type of cyclone are known as temperate cyclone. Temperate cyclone, they develops over the ocean and continents in the temperate zone, that is between 30 to 60 degree latitudes. 30 to 60 degree latitudes. So temperate cyclone develops over the ocean and continents in the temperate zone between 30 to 60 degree latitude. 30 to 60 degree latitude. Okay, temperate cyclone. So first we will discuss about tropical cyclone, then we will go for the temperate cyclone. I have just defined the things. I just gave you one term here. So first let us move on to tropical cyclone. We will see first thing, tropical cyclones. I told you where it is. They are in the tropical, they are found in the tropical region, and these cyclones generally develops over the tropical water bodies. In case of temperate, I have written both over the continent and the ocean, but tropical cyclone always develops over the tropical water bodies. So please note down first. These are very strong cyclonic disturbances generally develops over the tropical ocean and water bodies. Again I am repeating, tropical cyclone, these are very strong cyclonic disturbances. These are very strong cyclonic disturbances. Generally develops over the tropical ocean and tropical water bodies. Generally develops over the tropical ocean and water bodies. Okay, generally they develops over the tropical ocean and water bodies. Right. These cyclones are associated with very high velocity of the wind due to very high pressure gradient, very high pressure gradient. These are very strong cyclonic disturbances, generally develops over the tropical ocean and water bodies. The cyclones are associated with very high velocity wind due to very high pressure gradient, These cyclones has different name in different part of the world also. Okay, tropical cyclones, are called as typhoon, Bagu, Willies, hurricane, tornadoes. So tornadoes is a special case. Tropical cyclone, they are called as tropical cyclone in Indian Ocean. They are called as the tropical cyclone in Indian Ocean. Typhoon in Japan. Typhoon in South China Sea. Typhoon in Japan. Bagu in Philippines. Willy in Australia. Hurricane, generally it is called as hurricane in North America. It is called as hurricane. So tornadoes, USA. In exceptional case here, tornadoes are an exceptional case. They develops because of some other conditions also. They are very highly intensified, very strong cyclonic conditions. Very strong cyclonic conditions they are. So they are a different name at different regions of the world. They are asking sometime questions on this. इनका नाम कहाँ पे क्या है? Willy is in Australia, isn't it? So these are like the name of different region in different part. If you look at this, okay, very interesting. In USA, as I said, this is like Oklahoma state and all these regions. They are known as tornadoes also. Tornadoes is a special case. Tornadoes is a different one. Formation of tornadoes I will discuss. It is something different. Twister and tornadoes in USA. There are very extreme cases of this. Very extreme cases. they are associated with so much of air it shock from the below that sometimes even the if your door is closed in a house and all, if it will blast even. Blasting of the houses also takes place. Tornadoes reduces the temperature level, pressure level to so low that it has lot of problem even. Anyway, there are different types of these, like different names in different regions. In Australia, Willy Willy, Beguine, Philippines, Typhoon, Japan, Typhoon in South China Sea, tropical cyclone in Indian Ocean, USA, Gulf of Mexico region, hurricanes, North America. These regions you are having the name, same cyclone has a different name. These are tropical cyclone in different region. Let us see. First thing, conditions for the development of development of a tropical cyclone. What are the conditions for the development of a tropical cyclone? Very, very important. What are the conditions for the development of a tropical cyclone? The first and foremost one, presence of tropical water bodies. With presence of a tropical water bodies, or ocean, where average temperature is more than 26 degree or 27 degrees Celsius or more, where warm water at least 26 degree, preferably over 27, where the average temperature is more than 27 degrees Celsius, 27 डिग्री से ज्यादा होना चाहिए. So what will happen here? Because of this, evaporation will be more. If you have 27 degrees Celsius temperature, evaporation will be more. More evaporation leads to, if there is more evaporation, so evaporation leads to what? Moisture, whatever in the atmosphere, in that air mass will be rich, more moisture you will get. While the moisture layer goes upward, when it cool down, it releases heat energy, which is called a latent heat. Latent heat will get released. This latent heat is the major cause for supply of energy to this cyclone. Latent heat of condensation. Latent heat of condensation is the major cause, major factor for the development of a cyclone. I hope it is clear to all of you. Note down one more thing. High temperature, please note it down. High temperature leads to large scale evaporation. High temperature leads to large scale evaporation, which provides sufficient moisture to the air. 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 Okay. When WHEN, when water is converted into vapor, when water is converted into vapor, when the water is converted into vapor, a lot of heat is consumed. A lot of heat is consumed. When water is converted into vapor, a lot of heat is consumed, which is known as latent heat. Which is known as the latent heat. Which is known as latent heat. So, that's why, so moisture present in the air, provides necessary latent heat. moisture present in the air provide latent heat, and more the accumulation of moisture and more the accumulation of moisture and more the accumulation of moisture, more latent heat, more latent heat accumulation. मोर लेटेंट हीट एक्यूमुलेशन, ठीक है, एक्यूमुलेशन. सो जितना मॉइस्चर होगा इतना लेटेंट हीट सप्लाई होगा, राइट. दिस इज क्लियर. नेक्स्ट पॉइंट, व्हेन कंडेंसेशन टेक्स प्लेस, व्हेन कंडेंसेशन टेक्स प्लेस, जो मॉइस्चर ऊपर गया, व्हेन कंडेंसेशन टेक्स प्लेस एंड प्रिसिपिटेशन occur in the higher layer of the atmosphere, when condensation takes place and precipitation occurs in the higher level of the atmosphere, huge amount of latent heat released, huge amount of latent heat get released, huge amount of latent heat gets released, and which supply energy to the storm or to the cyclone, which supply energy to the cyclone. Okay. Next point. I hope it is clear to all of you. Ocean waters within the tropics or within the tropical region, ocean waters within the tropical regions are the warmest in late summer. Ocean water within the tropic or tropical region are warmest in the late summer and early autumn season. Late summer and early AUTUMN, autumn season. Consequently, most of the tropical cyclone develops in the autumn season. Consequently, most of the cyclone develops during the autumn season. Consequently, most of the cyclone develops during the autumn season. Hope it is clear now. Consequently, most of the cyclone develops in the autumn season, right? Dekho, one more thing here. South Atlantic, very important for you. South Atlantic and Eastern South Pacific. South Atlantic and eastern part of South Pacific. South Atlantic and eastern part of South Pacific. These two regions are impacted by cold oceanic current. South Atlantic, देखो यहाँ पे South Atlantic में, here you have which current? Here is a current, cold oceanic current known as Benguela current. Here is a current, Falkland current, cold current. So South Atlantic influenced by the cold oceanic current, as well as southeastern part of the Pacific, this one impacted by the cold oceanic current. That's why in these regions there is no development of tropical cyclone. Okay, again you note down South Atlantic, this region, South Atlantic. मैं एक डायग्राम बना देता हूं, बेटर रहेगा वो. Let me draw a diagram. Please look at this. It will be easy for you. South Atlantic. देखो यहाँ, this is here is Atlantic Ocean, this is South Atlantic and South Pacific. Now ये देखो यहाँ पे, here is a cold current and here also you have a cold current here. Here you have a cold current. So ये रीजन से ये कोल्ड करंट का नाम है बेंगुएला करंट. बेंगुएला कोल्ड करंट. ये है आपका FALKLAND, फॉकलैंड कोल्ड करंट. दिस इज हियर इज हम्बोल्ट कोल्ड करंट. कोल्ड करंट. सो ये जगह पे देखो, हियर बिकॉज ऑफ कोल्ड करंट हियर, ये तीन जगह में देयर इज एब्सेंस ऑफ दिस टाइप ऑफ व्हाट यू कॉल. देखो यहां ये रीजन में आपको कभी भी साइक्लोन डेवलप नहीं होता है. कौन सा रीजन है? दिस बॉक्स मीन दिस इज ईस्ट पैसिफिक, दिस इज साउथ ईस्ट पैसिफिक. साउथ, ये राइट हैंड साइड साउथ ईस्ट पैसिफिक एंड साउथ अटलांटिक. देखो आप, साउथ ईस्ट पैसिफिक एंड साउथ अटलांटिक you will not have any cyclone. Why? Because this region is influenced by the cold oceanic current. Temperature is less here. No such any cyclonic development. ये प्रीलिम में आ सकता है कि ये क्यों नहीं होता है यहाँ पे. I hope you will get the things. So temperature plays a very important role. मैं टेम्परेचर का बात कर रहा हूं. Now I am talking about only temperature. I said 27 degrees Celsius temperature is necessary because this temperature promote evaporation. Evaporation होगा तो moisture laden air will move vertically upward, while the moisture will go upward because it requires lot of heat for evaporation. Evaporation होगा तो heat energy trapped होकर रहता है. This heat energy, while it goes up, this moisture laden air, when it cool down, ऊपर जाके जब cold हो जाएगा, ठंडा हो जाएगा, condensed होगा, so there will be release heat energy known as the latent heat of condensation, and this is what it gives power. It is give energy to the cyclone. That's why cyclone always develops over the tropical water bodies. And strength of the cyclone depends on its stationary period over the ocean. Ocean में जितना टाइम तक रहेगा उतना स्ट्रांग होते जाएंगे. The more stationary period of the ocean, more will be the strength of the cyclone, destructive power of the cyclone. Okay, tropical cyclone. Now, ये जो regions मैंने कहा, Benguela current is in this ocean current. I haven't discussed. Let me tell you one thing here. Ocean current क्या होता है? Large scale displacement of the water in a defined direction in the ocean is called as ocean current. ये कोई भी वजह से, कोई भी फैक्टर से अगर लार्ज स्केल में वाटर अगर डिस्प्लेस हुआ इस पे, इसको बोलेंगे ओशियन करंट. इफ द वाटर इज कमिंग फ्रॉम द पोलर एरिया का कैसा होगा? पानी ठंडा होगा टुवर्ड्स इक्वेटर. इफ इट इज कमिंग, इट इज कोल्ड ओशियन करंट. इफ द वाटर फ्रॉम द इक्वेटोरियल रीजन इज गोइंग टुवर्ड्स द पोल, इट इज वार्म ओशियनिक करंट. इफ इट इज ए कोल्ड ओशियनिक करंट, देखो ये पोलर रीजन से आ रही है ना, कोल्ड ओशियनिक करंट है. कोल्ड ओशियनिक करंट है मतलब द थिंग इज, इफ इट इज कोल्ड ओशियनिक करंट, दिस रीजन हैज फ्लो ऑफ कोल्ड वाटर. सो कोल्ड वाटर फ्लो मीन द एयर अबव द कोल्ड वाटर रीजन्स इज कूल. इसके ऊपर जो हवा होंगे, एयर अबव द कोल्ड ओशियनिक region or cold ocean current regions will be cold. So there will be no evaporation because it's cold water. There will be no evaporation. So it restricts the development of a cyclone. It restricts the development of a cyclone. That is the cause South Atlantic and Southeast Pacific region have no cyclones, no tropical cyclone. Done? Okay, fine. I told you about the first things. Presence of tropical water bodies, ocean current above ocean average temperature should be more than 27 degree. So it will have more and more evaporation. It is very much essential. First and foremost point, I hope you got it. Warm water should be there. पहला सबसे important है warm water. Okay, clear to all of you. Second point is, let us move on to the next point. Second point, I hope it is clear to all of you. First point is clear to you? Clear hai? Any explanation you need? I hope it is clear. Now second point is, see, not only temperature होगा तो sufficient नहीं है, उसके साथ साथ क्या है? Depth of the ocean should be there. Depth of warm water. Okay. Depth of warm water zone should be कितना होना चाहिए? 60 to 70 meter at least. At least 60 to 70 meter. At least 60 to 70 meters. Depth of warm water zone should be at least 60 to 70 meters. Minimum the 60-70 meter होगा. अगर डेप्थ तक अगर वार्मिंग अप नहीं हुआ, then the cold water can come up because of upwelling and it may affect the temperature. You got it what I am saying? No. What happened? If only surfacial, ऊपर ऊपर ही पानी अगर गर्म हुआ, so there is possibility even due to any cause, if upwelling of water takes place, नीचे से पानी ऊपर आ गया, There are cases of upwelling in the ocean, we will discuss later on. Oceanography में discuss करेंगे. So if the water from below will come up, cold water it is. नीचे का पानी ठंडा है. This cold water which will come up, the air above this will be cool one. It will restrict evaporation. So at least 60 to 70 meter of warming up of the water should be there. So evaporation will be better. Depth of the warm water, sea water temperature 27 degrees at the sea surface alone is not sufficient. High temperature the 27 degree prevail from the sea surface up to a depth of 60 to 70 meter. आपका जो टेम्परेचर जो है 60-70 मीटर तक ऐसे होना चाहिए, 60 to 70 मीटर. अरे ऐसे तो 27 degree Celsius anywhere you can get it. You know that in Kolkata and nearby regions 27 degree Celsius is an average temperature we are getting sometimes summer season, more than that. So everyday cyclone होना चाहिए. Why will not have this? Because it requires substantial depth, 60 to 70 meter of depth of ocean water should be around 27 degrees Celsius. This is also second condition. Okay, I hope you got it. Third point, तीसरा point है, my friends you must remember this, ये बहुत important हमारा exam के लिए, mains के लिए, very important for us. Okay, depth of warm water zone should be at least 60 to 70 meter. 60-70 मीटर का जरूर होना चाहिए. और एक बता रहा है क्या, डेप्थ ऑफ वार्म वाटर के बाद we can have divergence in upper troposphere. Divergence in the upper troposphere. You must remember this. अगर ऊपर लेयर में डाइवर्जेंस हो रहा है तब तो नीचे से हवा ऊपर आएगी. If there is divergence in the upper atmosphere, then only it will suck the air from below. The cyclone will be developed properly if you have proper, in this case you see here, यहां पे अगर डाइवर्जेंस हो रहा है, if there is divergence in this upper part, look at here, if there is divergence at the upper part, ऐसे डाइवर्ज हो रहा है, then it will be easy for the development of a cyclone. Divergence in the upper air is very much necessary. Note down here, divergence in the upper atmosphere. Divergence in the upper atmosphere is very much necessary, is not it? Divergence in the upper atmosphere is very much necessary. Upper atmosphere अगर divergence होगा तो this can move upward very quickly. Air can move upward very quickly. I hope it is clear. Divergence. Upper atmosphere divergence must have well developed divergence in the upper part. It will strengthen the inflow of air below. ये नीचे, ये ऊपर suck कर रहा है तो ये नीचे से ये. This will converge and goes up. It will intensify the development of cyclonic conditions. Okay, disturbance in upper atmosphere. Okay, another one, another point. Third point is clear to all of you. Fourth point now. Fourth point is presence of pre-existing low-level disturbances. Presence of pre-existing low-level disturbances. Presence of pre-existing low-level disturbances. अगर लोअर एटमॉस्फेयर में कोई डिस्टर्बेंस पहले से है, आई मीन इफ देयर इज सम low pressure condition already there in the lower atmosphere and the convergence of air is already going on, that will be the most suitable place, most suitable condition for the development of a cyclone. It will have more suitable condition for the development of a cyclone. I hope it is clear to you, right? Presence of pre-existing low-level disturbances strengthen or trigger the mechanism of or intensification of a cyclone development. See the case here. Here the cyclone development हो रहा है यहाँ पे. Already if there is a low pressure condition already develop किया था, तो then you have a very easily it will develop. Very easily it will develop. अच्छा ये आपको समझ में आ रहा है? This is on the surface. And ये जो है ना ऊपर से अगर देखेंगे horizontally, this is horizontal one, this is vertical. दोनों एक साथ दिया हूं मैं. This is horizontal one. ऊपर से इसे देख रहे हैं horizontally. Howdy, and this is vertical cross section is there. Okay. So this is here you can see. This is horizontal, this is vertical. ये surface के ऊपर vertically कैसा है? ये horizontally surface में कैसा है? So you have got these things. Right. Presence of pre-existing low-level disturbances like the shifting of ITCZ. कैसे होता है? Intertropical convergence zone. So ITCZ while it shift, it develop, in fact trigger the low pressure condition again. It trigger, strengthen the low pressure conditions, intensify the cyclonic development of a region. ये भी इंटेंसिटी बढ़ा देता है. लो लेवल डिस्टर्बेंसेस ईस्टर्ली वेव से स्टार्ट होगा एंड डेवलप दिस. ओके, लो लेवल डिस्टर्बेंसेस आर देयर. Another one, fourth point गया. Fifth point is sufficient Coriolis force. Coriolis force. Coriolis force. Sufficient Coriolis force should be there. Most essential prerequisite for movement of air in a cyclone. Most essential prerequisite. Most essential prerequisite for movement of, most essential or prerequisite for the movement of a cyclone is Coriolis force. अगर नहीं होगा Coriolis force तो क्या होगा? There will be no twisting, no whirling of the air. If there is absence of Coriolis force, there is no whirling or twisting of the air. Because there is no whirl or twist of the air, that's why you will not have a cyclone. Cyclone will not develop because of if there is no such any Coriolis effect, and this is the cause absence of cyclone you have at the equator. Note down here. Due to this, there is no cyclone at the equator. At the equator will not have. One of your friend is asking why cyclones are frequent in Bay of Bengal and rare नहीं कहेंगे, Arabian Sea. Frequency is less in Arabian Sea nowadays. We will come to that. क्यों होता है? एक तो factor है ही. What is that factor? Do you know? Temperature. Look at the Arabian Sea and Bay of Bengal. Arabian Sea depth is less. Less? No. Arabian Sea depth is more. Bay of Bengal depth is less. Bay of Bengal depth is less, enclosed in three sides by the continent. Bay of Bengal. आप ये दोनों में देखो यहाँ. Here you see. Arabian Sea को देखो. वाइड है, बे ऑफ बंगाल इज एनक्लोज्ड है, एंड enclosed है. Here you have more and more water, fresh water is coming. Salinity, if you see, salinity of Bay of Bengal is less than Arabian Sea. Less saline है, evaporation rate is very high here. Evaporation जल्दी होता है यहाँ, in this case, and that is the cause, you know, more intensification. And nowadays there are few triggering factors also, we will discuss subsequently. So one, this is the factor here. Another, minimum vertical wind shear. Sixth point is minimum vertical wind shear favors the development of a cyclone. अगर विंड शेयर ज्यादा होगा ऊपर में, वर्टिकल विंड शेयर मतलब वर्टिकली जो ऊपर जाएंगे, when the air moves, there should not be change in more direction of the wind. So in that case, if there is more direction of wind अगर ये होता है तो ये क्या latent heat को absorb कर लेगा. It requires latent heat, more and more latent heat. So wind shear is not, wind shear will be there, but it should be less. Okay. मिनिमम वर्टिकल विंड शेयर, मैक्सिमम होगा तो लेटेंट हीट लॉस हो जाएंगे, दैट्स वाई. सो लिखो, फॉर प्रॉपर डेवलपमेंट ऑफ ए साइक्लोन और ट्रॉपिकल साइक्लोन, फॉर बेटर डेवलपमेंट ऑफ ए ट्रॉपिकल साइक्लोन, it is necessary that the wind shear between lower and upper atmosphere, that the wind shear, SHER, shear between the lower and upper atmosphere must be minimum or must be minimal. Must be minimal. देखिए, पूरे यूनिफॉर्म भी नहीं होना चाहिए. कंप्लीटली यूनिफॉर्म ऑल्सो, यूनिफॉर्म इफ इट इज देयर ऑल्सो स्टेबल भी है, वहां पे भी नहीं होगा. बहुत ज्यादा डिस्टर्बेंस होगा, वहां भी नहीं होगा. सो ए मिनिमम वर्टिकल विंड शेयर इज नीडेड, बट इट शुड नॉट हैव मोर. मिनिमम वर्टिकल wind shear should be minimum. This is here. Okay. Another one, high humidity condition. Okay. High humidity in the air. High humidity in the air is again one more very important factor, because it helps in the development of cumulonimbus cloud along the eye wall. It helps in the development of cumulonimbus cloud. You know that this generally helps in quick movement of upward vertical movement of the air mass, quick vertical movement of the air mass also. It helps in the quick vertical movement of the air mass. So these are the factors, as I said, these are very important factors, I said, responsible for this. Okay. So how many? 7 factors I said. 7 factors. Right? Any disturbances in the upper atmosphere also leads to this type of formation. Divergence hoga, upper atmosphere, I told you, these are the cases. So these are the factors, favorable condition for the development of a tropical cyclone, right? So tropical cyclone generally develops because of high convectional instability and in a phased wise manner it usually develops. Let us see now development of cyclone. Development of a tropical cyclone. Due to intense temperature and convectional instability, due to intense temperature and convectional instability, a tropical cyclone develops in a sequential manner. In a sequential manner. Formation phase, developing phase, mature phase and dissipating phase. 4 phases are there. 4 phase में इसका development होगा. What are those? Let me tell you. It develop with 4 phases. फर्स्ट फेज का नाम क्या है? फर्स्ट मैंने कहा यू हैव फॉर्मेटिव फेज. फॉर्मेटिव फेज, फॉर्मेशन टेक्स प्लेस. कंडीशंस जो है ना, मैंने बोला सब कंडीशन वहां डेवलप होगा. देन डेवलपिंग फेज, developing phase. Development will be there in this phase. Then we have mature phase. Mature phase. Developing phase. Then we have the mature phase. And finally you have dissipating phase. Dissipating phase. 4 phases में होगा. Formative, developing, mature, dissipating. Dissipating phase. Gradually, step by step, we have it formed in a sequential manner. It will form. It will form in a sequential, formative, developing, mature and dissipating phase. What is there? Formative phase में in the formative phase, in this phase, what happened here? The temperature rises and pressure level significantly decreases. Pressure level significantly decreases here. प्रेशर कंडीशन जो है ना सडनली डिक्रीज होगा फॉर्मेटिव फेज में, राइट. सो व्हाट हैपेन इन दिस केस? आइसोबार became circular in shape and closely spaced with increasing gradients, increasing pressure gradients with increasing pressure gradients. Okay. Isobar became circular in shape and closely spaced with increasing pressure gradients. With the increasing pressure gradients. So all favorable, all the above conditions, all the favorable conditions gradually achieved. Conditions for cyclone development. For development of a cyclone gradually achieved. It will gradually achieved here. For the development of a cyclone, all the necessary conditions what is required will gradually achieved here. Then second is developing phase. ये हो गया आपका पहला फेज में. सेकेंड फेज पे आते हैं. Developing phase. In this case, what will happen? Developing phase में there is a further fall in the pressure conditions and rise in the convectional instability develops with the formation of a cyclone. Gradual rise in the pressure gradient due to falling pressure condition gradually rise in the pressure gradient due to falling pressure conditions at the center of So in the isobar at the middle part we have lowest one. So what will happen? Vertical rise in the air due to convectional instability, and gradual whirling of wind as a result of Coriolis effect. Below the Coriolis effect, vertical rise and gradual whirling of the wind started. Gradual whirling of the wind started. Now what will happen? Vertical rise in the air due to convectional instability and gradual whirling of wind as a result of Coriolis effect. So क्या होता है देखते हैं अभी. Divergence on the upper atmosphere at the divergence at the upper atmosphere strengthen the rising and whirling air. Consequently, developing a cyclonic system. Cyclonic system. एयर ऊपर से डाइवर्स कर रहा है तो इट विल सक अप वेरी क्विकली एंड व्हिर्लिंग ऑफ दिस टेक्स प्लेस एंड दिस विल डेवलप इन दिस वे डेवलप्स ए व्हाट इज डेवलपिंग फाइनली ए cyclone is developed here. Divergence at the upper atmosphere strengthen the rising and whirling air, consequently developing a cyclonic system. Okay, with a circular movement of wind takes place here. Then it paves the way for the development of mature stage. Third stage मैंने कहा था क्या? Third stage is mature stage. Third is mature stage. This one, this stage it will have. Mature stage will have the mature stage here. Mature stage. Fullest development of a cyclone takes place in this case. Fullest development of a cyclone takes place. Fullest development of a cyclone takes place. Fullest development of a cyclone takes place. Full development of a cyclone, okay, with the wind speed of 60 km or more. With a wind velocity of 60 km per hour. Per hour. According to the Indian Meteorological Department, IMD, when the wind velocity is 90 km per hour during a severe cyclonic storm, according to the IMD, Indian Meteorological Department, it will be a severe storm, severe cyclonic storm. If it is 90 km per hour, 90 km per hour, okay. Severe cyclone storm with a core of hurricane. Severe cyclone or storm with a core of hurricane. Core of hurricane. If it is 120 to 220 km per hour, 120 km per hour, 120 kilometer per hour. 120 kilometer per hour. When it is more than 220 kilometer per hour, it is called as super cyclone. Super cyclone when it is more than 220 kilometer per hour. According to IMD, साइक्लोन कितने में 60 किलोमीटर पर आवर में, साइक्लोन 60 किलोमीटर पर आवर, सीवियर साइक्लोन 90 किलोमीटर पर आवर, सीवियर साइक्लोन storm, severe cyclone storm with a core of hurricane 120 kilometer per hour, 220 or more is super cyclone over 220 kilometer per hour. ओके ये जो है ना डेवलपमेंट होते हैं ग्रेजुअली अंडर यूनिक कंडीशंस, दे यूजुअली डेवलप लाइक दिस. सो दीज आर डिफरेंट थिंग्स. Cyclone, severe cyclone storm with a core of hurricane or super cyclone. You are using also different things here, like ये जो cases है 180 किलोमीटर में भी in some of the cases some conditions under which we consider the super, not 220, 180 to 220 to 30 kilometer speed also we have taken at the wind velocity, also it's called as the super cyclone. ये भी कहा गया है. By the way, as I have just mentioned about this, I hope you got some idea now. The fullest development of a cyclone takes place with the whirling of the wind. It tries to throw out everything upward. It tries to throw out everything upward. Super cyclone will develop here. After completion of the cyclone, we have dissipating phase. Fourth stage is called as dissipating stage. Dissipating phase, in which gradually the cyclone will dies out. Okay, cyclone leaves the sea area, enters the land area, called as the landfall takes place. Cyclone reaches the land area from the ocean, so landfall takes place. Supply of moisture stopped. So the cyclone supply of moisture gets stopped. Supply of moisture बंद हो जाएगा. Moisture supply will be stopped here. So the cyclone will not get latent heat. And its strength gradually declines. Finally, it dies out. The cyclone will dies out finally. After the landfall only it is possible. This is possible only after the landfall. Okay? This is possible only after the landfall. So 4 phases hai. I told you formative phase, then you have the developing phase, mature phase and the dissipating phase. 4 phases in the development of a tropical cyclone takes place, and step by step they develop and finally it dies out. Okay. So in a cyclone, as I have just mentioned, the air here will converge. In this case, it will converge vertically, it rises and finally it will develop like this. Let us look at now structure of a cyclone. Structure of a cyclone, tropical cyclone. As I have just mentioned earlier, in a cyclone we have this is the structure of the cyclone. Here you see, this is the structure of the cyclone. Here I am saying this region as region with, you see, vertically eye of the cyclone. Here it is eye wall. It is called as what? EYE, eye wall. Eye wall of the cyclone, it is eye wall. And remember, at the middle part we have the eye of the cyclone. You must remember this. This is as the eye of the cyclone. Please draw this. Eye of the cyclone, eye wall of the cyclone. You can see this. Spiral bend or the rain bend you will get out of this. Spiral bend. This is known as the this is the cumulonimbus cloud. Here you have the cumulonimbus cloud here. But in the upper part you will have the cirrus cloud also. Cirrus cloud. In the upper part you can have the cirrus cloud. Cirrus cloud also in the upper part. And you see here, because of more and more whirling of this, what will take place? Very interesting to note here. देखो यहाँ से हवा जो है ना नीचे भी जाएगी और ऐसे ये थ्रो करेगी. Can you just see these things? How I am drawing, you just see. It will also throw the air. Why sinking takes place at the margins of this? Sink करेगा यार. Why it will sink? You know, because of mechanical factor. Because it circular movement there, eddy formation is there. Eddy formation. This sinking is due to eddy formation. EDDY, eddy formation and sinking of this. Eddy formation and sinking of this. Sinking takes place. जैसे आप एक लस्सी बनाते हो ना, या something you are grinding, okay. Well, it rotates circular motion and more. It is there at the middle part. You have sinking of the things takes place, and you must have seen this. Same way it will happen. A very important this one. I got few very interesting questions from my friends here from Kolkata and West Bengal. एक बहुत बढ़िया question है. Somebody is asking why cyclone is rare in Arabian Sea but Bay of Bengal. Okay, we will have this. How to look at cyclone formation before 20-30 days for formation of a cyclone? Krishna is asking this question. My friend, you see here. A cyclone formation prediction is based on, you know what, upper air circulation. We have computer simulated model. We have Doppler radars. You are getting continuous information from the stations, from the sea ocean itself. What is the ocean temperature, what is the air condition, what is the low pressure condition, upper air, where you have what type of condition is there. We have all the information about the upper atmosphere. We have information about the ocean surface water conditions and temperature and the wind direction, etc. And this leads to, we have a computer simulated model on this, which always gives us probability, possibility, and what way it is possibility is there, to what extent it will be, in that case it will go. So we have three processes on this. One, based on the last 30 years of experience, how it is tracking. Second, based on the present condition about the physical conditions of the temperature and pressure condition of that entire region. Third, तीसरा जो है सबसे important है, which is about the near seesaw atmospheric conditions, especially in the upper atmosphere. Upper atmosphere is also sometimes playing a very significant role on establishment of a cyclone in a particular region. ये तीनों को लेके हम लोग ये कराते हैं. We are doing this with the help of these three only. Very important it is. So Krishna, 20-30 days in advance is very difficult to get, but yes, we can say there is possibility, but we cannot predict it properly. Like in the presently this cyclone which happened just couple of days, one last week, this cyclone in West Bengal, Bangladesh, which is in that region of Bay of Bengal cyclone which we had. So in that particular cyclone, we first thought that okay, it will strike over Andhra Pradesh, then Odisha, then Bengal, West Bengal coast, then Bangladesh. So like we have changed our perception because the earth atmosphere is very dynamic one. So computer simulated model through which you are doing the things, provided we have the ground data which is very authentic one. If you don't have the proper ground data, it is very difficult for us to predict. Okay. For the formation of super cyclone, how much latent heat will be needed? My friends, suddenly, if it is the recurving of the anywhere, if there is recurving of the cyclone takes place, there is a great possibility of super cyclone. ये जो cyclone अभी गया ये super cyclone बना होता अगर recurving और हुआ होता. So more stationary period over the ocean will have this type of formation. So a quantitative approach we cannot say that, but it should be very strong enough. It depends on the dimension of the a tropical cyclone, whether radius is how much, 100 kilometer or 20 kilometer or 200 kilometer. So smaller the diameter, more the intensification, and the destruction rate will be very high. Super cyclone generally develops with a less radius or diameter of a cyclone with very high velocity of wind. Wherever there is sudden rise in the air parcel upward, there is possibility of super cyclone. Can you tell us the naming of cyclone takes place? Yes, we have it. We'll discuss about that. Naming of the cyclone we'll discuss. Today it is not possible, I think, but we'll discuss about this. Tomorrow also I'll continue with the cyclone. मैं चाहता हूँ आप थोड़ा पढ़ के आए. In fact, after a long break we got the things here, so maybe थोड़ा सा आपको आज परेशानी हुआ होगा, but I'll try my best. Animations I'll give you tomorrow. I have that, all those things. Cloud and this one also, some animation also I'll show you. My request to all of you, please have a glance over this, and in your material, among these, क्या देखना है? Only NCERT. You see only NCERT climatology part I have already given. I told you earlier. Cyclone देखिए, this diagram is given. How it is sinking. यहाँ confusion होगा आपका. You might have some. You definitely will have some confusion on this part. That why it will going down? ये तो ऊपर जा रहा है, ये क्यों? Because of more, circular movement and eddy formation. Sinking of this takes place. It is sinking below. It is going down, and this is mechanical factor. Mechanical factor है. So where is the wind shear zone? Wind shear zone, vertical wind shear. So आप जो ऊपर जो air circulation में बताया नहीं, day after tomorrow or tomorrow if possible after tropical cyclone temperate में बताएंगे कि there are some regions in the upper atmosphere, wind velocity is more. If wind velocity is more, it is trapped in that type of condition, it will take away everything, one direction. Divergence नहीं है वो, ऐसे चला जाएगा wind के साथ साथ. Divergence is different from wind shear. Wind shear में क्या है कि that if there is change in the direction, ऊपर जा रहा है हवा ना, वो wind shear होना चाहिए, मगर it's not like at one place at a particular level only. Suddenly it will change direction and flow. Outflow खाली नहीं होगा. We have to move this. ऐसे move करने के लिए there is enough what you call wind shear. Very slow wind shear should be there. बहुत ज़्यादा नहीं, बहुत ही कम नहीं. अगर ज़्यादा है तो it can take away all these what I said. Latent heat will get destroyed. Sometimes small whirling air is seen on the land. What is that, sir? Please explain. This is here is convectional instability. Same process like cyclone. बवंडर जो होता है cyclone ही जैसा है, but over the continent. If it will develop over the ocean, it will develop as a cyclone. Okay, same process itself. Only latent heat will be there in that. Why cyclone move towards land area? Always you remember wind blow. देखिए लैंड एरिया की तरफ आएगा ही, लैंड ओशियन है, ओशियन से लैंड को आएगा ही. देर आर साइक्लोन इवन ओवर द ओशियन ओनली एंड दे डिडंट डाइज आउट बिकॉज कंटिन्यूअस सप्लाई ऑफ मॉइस्चर तो रहेगा, सो मोर स्ट्रॉन्गर इट विल बी, बट डेफिनेटली फाइनली इट विल कम टू द लैंड एरिया बिकॉज हियर ओनली इट विल डाइज आउट. जब लैंड एरिया के ऊपर आएगा तभी जाके इसकी डेथ होगा. इट विल डाइज आउट ग्रेजुअली बिकॉज ऑफ द प्रेशर ग्रेडियंट दे यूजुअली कम्स फ्रॉम द ocean to the continental part. Please give me questions, whatever doubts you are having, I will answer it now. Now let us see. Divergence हो रहा है यहाँ पे, sinking of the air. Structure of the cyclone, if you will see, there are distinctive zones in this. Please note down what are those. So note down here, there are distinctive zones. If you look at the structure of the cyclone structure, tropical cyclone structure में ये बनाना है आपको. This is eye wall. This is eye, and this is here is like the annular zone, spiral zone. eye wall के बाद spiral band होता है, rain band. इसको बोलते हैं rain band और spiral band. ये जो है ना, this is known as the rain band because it gives rainfall here. ये regions में it is ये हो गया आपका, it gives rainfall, so it is known as the rain बैंड. आई के बाद आ जाता है आई वॉल, आई वॉल के बाद आ जाता है रेन बैंड. फर्स्ट इज आई, आई इज नंबर 1, देन नंबर 2 इज आई वॉल, नंबर 3 इज रेन बैंड. देख रहे हैं आप, रेन बैंड इज देयर, स्पाइरल बैंड और रेन बैंड. ओके, नंबर 4 एनुलर जोन. नंबर 4 हियर इट इज नोन एज द एनुलर जोन. ANNULAR, annular zone. Here also it is annular zone, ANNULAR, annular zone. Number 4 is annular zone. Beyond the rain band, you have annular zone. Then you have outer convective belt. Outer convective belt, ये जो ना ऊपर भाग रहा है, ये सब चीजें outer convective belt है. So these are here. All these things develop. We will see all those areas in detail. ये सभी को एक एक करके देखेंगे. One by one we'll see. So first is in the structure of the cyclone. First is at the center you have eye of the cyclone, isn't it? मैं कहा at the middle of the cyclone you have the eye. So first one, structure of the cyclone में पहला पॉइंट जो है eye of the cyclone. Very interesting है ये. Eye of the cyclone. Note down one point here. One thing here. At the center of the cyclone, where you have highest temperature and lowest pressure, at the center of a cyclone, where highest temperature and lowest pressure zone develops called as the eye of the cyclone. Eye of the cyclone. Highest temperature, lowest pressure. Highest temperature and lowest pressure called as eye of the cyclone. Highest temperature, lowest pressure. This here is the eye of the cyclone. Middle part of the cyclone is the eye of the cyclone. So this region is relatively calm and quiet area with no cloud coverage. It is a calm and quiet zone. It is a calm and comparatively calm and quiet zone with clear sky, no clouds, clear sky here, completely clear sky. Calm and quiet zone, मतलब silent zone. It is a silent zone. It is a completely silent zone. Calm and quiet means silent zone. Very, very important with this is this zone is associated with even here there is no cloud because everything got they got dissipated. अब देखो यहाँ पे कहाँ से और क्लाउड होगा, ये रीजन्स में ये हवा तो इधर इधर चल रहा है, क्लियर स्काई होगा ये. दिस जोन हैज क्लियर स्काई. एट द मिडिल यू हैव द क्लियर स्काई. बिकॉज इट हैज क्लियर स्काई there is no, even in this case rainfall will also not there. Lowest pressure, highest temperature. Lowest pressure and highest temperature here at the eye of the cyclone. Another point here is at the margins of the eye, a dense vertically developed cumulonimbus cloud zone develops called as the eye wall. इसको क्या कहते हैं? Eye wall. At the margins of the eye there is a vertically developed, very dense cloud zone with cumulonimbus cloud is found, and this is called as the eye wall. This is called as the eye wall. Eye wall is there. Eye wall is vertically developed one, and it is completely made up of the cumulonimbus cloud. It is made up of the cumulonimbus cloud, I said. Eye wall is made up of the cumulonimbus cloud. Okay, eye wall. The boundary of the eye is divided into eye wall. Okay. So, eye wall forms the boundary of an eye of a cyclone. Okay, eye of a cyclone. The eye of the cyclone varies from 7 km to 200 km in diameter. Eye of a cyclone varies from 7 km to 200 km in diameter. डायमीटर वेरी करता है. Whenever the cyclone gets intensified, the eye shrink, okay, or contracts. During the intensification of a cyclone, of a tropical cyclone, the eye gradually contract or shrink. So जितना छोटा आय होगा इतना ज्यादा इंटेंसिफाइड होंगे. Smaller the eyes, more will be the intensity of the cyclone. Larger the eyes, intensity will be less. Smaller the eyes, more intensity. You must remember this. Okay, so this is one again another very. Okay, eye can be elliptical or even whenever it intensified it become very circular. Shape of the eye is circular in the highly intensified tropical cyclone generally develops a circular isobar. Highly intensified tropical cyclone generally develops a circular isobar. Highly intensified tropical cyclone generally develops a circular isobar. You must remember this. This is all about the cyclone, your eye of the cyclone. And eye of the cyclone is generally nearby we have the eye wall. So eye wall is generally made up of what you call, second point is eye wall. अभी eye wall पे देखते हैं. Eye wall very dense and thick zone of cumulonimbus cloud with very dense and thick zone of cumulonimbus cloud with very dense and thick zone of cumulonimbus cloud surrounding the eye of a cyclone. Eye of a cyclone. It is associated with heavy rainfall and very severe wind, whirlwind, very severe whirlwind. Twisting of the wind is there. Whirlwind you have, severe whirlwind with this. Okay, I got some question now. Let me answer this. Then tomorrow I will continue with this structure of the cyclone. So you have some question, good number of question you are having. So let me take one by one. One question here. Sir, I didn't understand corona formation of stratus cloud in low cloud regions. Corona formation क्या होता है? You know what happened? We will not able to see clearly the entire regions, rather peripheral area, तो photosphere होता है ना, sun की जो photosphere है, that will be visible generally the outer ring type, and this is because of again an optical illusion like it happens. In this there are ice crystals also, but here you have like in the lower case of cloud here there will be transparency will be less, that may be the cause. कल हमने एक फोटो दिखाएंगे आपको. Tomorrow I will show you a photo on that corona and all. I will show you. Okay. Another questions I got. So tomorrow I will answer this with the picture on that. Where it is? Nimbostratus cloud ka. One more questions I got. Naming of the cyclone will be tomorrow. Okay. Sometimes small whirling air seen in the land. Yes. Why cyclone move towards the land area? To maintain equilibrium. Always the wind blows. See that continent get heated up very quickly as compared to the ocean. So low pressure condition will be developed over the continent, no doubt, and that is the cause. Usually air wind blows from this side. That's why with this the entire cyclonic system also move toward the continent. What is landfall? When the cyclone strike over the continent, when the cyclone strike over the continent or the land mass, it is called a landfall. The place where landfall takes place is the most destructive area. It gets maximum destruction. Landfall area has maximum destruction. Area of landfall has maximum destruction. After the landfall, there will be the cyclone will be away from the ocean. Rather, it moved over the continental part. Because it travels through the continent, there is no supply of further moisture. Because there is no supply of moisture, it gradually dies out. Death of the cyclone or cyclolysis takes place. Death of the cyclone is known as cyclolysis. Death of the cyclone takes place with this landfall. Is eddy wind cold or warm? Eddy wind are like the wind system, as you know, whirling wind is eddy wind. It is warm wind, but it goes down because of mechanical cause. ये जो जाता है नीचे warm wind है, but नीचे जाते हैं क्यों? Because of the mechanical factor, not the thermal factor here. If eddy formation causes shrinking of air, is there high pressure along the eye wall? No. ये eye wall के side से high wall में देखो आप, no high pressure condition here. क्यों पता है? At the margin maybe there, it is a very complex cycle, in fact very complex system है ये. देखो आप यहाँ पे, you are talking about this because why there will be no, this one like it is going out again. देखो ये throw कर रहा है फिर. Have you seen this? It is going down, throwing like this. It is temporary conditions here we have like this. It is throwing out again. This current is much strong. This current यहाँ से जो आ रहा है strong है और इसको ये उठा के ले जा रहा है. फिर again it is taking going out. ये तो फिर again it is going out here. That's why it is a relative temporary phenomena. When can we find distinct seasonal variation in the tropical or temperate zones? Where can we find distinct seasonal variation in the tropical or the temperate zones? Why you are asking this? Okay. You remember seasonal variation will be more. Both tropical और temperate दोनों में seasonal variation होगा. For an example, tropical will have less as compared to the temperate. No, temperate will have more comparatively, but continental part of temperate will be more. Where can we find seasonal variation more? More seasonal variation will be in the temperate zone. If we given a tropical and temperate zone, answer direct. But again, in the temperate zone, it is at the middle part of the temperate zone. That is in the continental part, not at the coast. Okay. How is the temperature of eye of cyclone? How is the temperature of eye? My friends, you remember, eye of the cyclone has the highest temperature and lowest pressure. Freezing or cold or warmer? Eye of the cyclones has always highest temperature. Freezing होगा नहीं, cold भी नहीं होगा, ये very high temperature I said. Because of mechanical cause, it only sink down. Now I am requesting again, do study the fundamentals of physical geography, climatology part, cyclone, there is a chapter on cyclone. You got it what I am saying? The NCERT book of class 11th, cyclone, or in our KSG material, if you don't have the NCERT, look at our KSG material, physical geography section, in which we will find out the same thing. Okay, you will find out the same thing. Climate part, let me tell you the page number also, which pages we have to see or study. Okay, page number 347. This is the book here. Page number 347 of our KSG booklet. 347, 348, 349. Okay. 348, 347, 347, 48, 49. You can study this. Temperate cyclones, everything is given here. कल ये पूरे चैप्टर को पढ़ के आइए. आप chapter number 26, precipitation, we have done this. Cloud formation, we have done this. Air mass and all these things are given. Chapter 25, today we have done. Chapter 25, 26. Do study and come. 25, 26. आप पढ़िए इसको from this booklet which you got it. Chapter 25, 26. If you don't have the NCERT, don't worry. You can study, you can see this book, these pages of this booklet. Okay. Kindly look at the previous year questions. Kindly say the multiple MCQs, whatever they are, previous year as well as practice set. If you have anything, we will discuss it tomorrow. We will discuss it tomorrow with this in detail. Any other question, please let me know. Today, in fact, because I started and you are not prepared with this, so I will not cover much here. I will leave you here. But I want you must study. Tomorrow I will discuss 3 things. What are those? Let me tell you. आपका उसमें अपडेट करेंगे आज कोर्स मॉड्यूल जिस पे भी on site will update that one. Tomorrow I will have tropical cyclone. I complete this. Then I go for air mass. I'll go for temperate cyclone. Temperate cyclone. Then I'll comparative analysis. Comparative analysis of tropical and temperate cyclone. Temperate cyclone. Then if possible I'll go for jet stream. Jet stream. Okay. Tomorrow is very, very crucial, very important topics. These are we are going to discuss. Okay. Why cyclone form in Andaman Seas often tends to be bent towards Bengal, Andhra Pradesh, Odisha, not towards Tamil Nadu? See, while it move, you know that Coriolis force in northern hemisphere, Coriolis force is there. So Coriolis force try to bend them towards right and right and right. That's why they move in this way. Okay, Coriolis force. Is there another question here? As there is divergence in the upper troposphere, then from where eddy wind comes. Okay, divergence जो upper atmosphere में है, it is in the precondition. After development of the cyclone, cyclone developed as an independent unit, and it rotate it individually, and it act as a, you know, like a what you call thermal engine like. Now, while it develop, completely develop, precondition is required of divergence, but once it develop, it throw itself and sinking of the air takes place. It became a self-sustaining system after formation. Okay, got it? But very good question. Thank you very much. I got a very good question, and thank you very much. Lot of please do participate. Okay, in my session at least. Please, whenever you have anything, please ask me, and you have my number also. If required anything, please do that. Do ask me if you have any problem. Okay. See friends, because I haven't informed you earlier, so it may take some time for you, but I request you all to just whatever we have studied today, revise it, read it from either from NCERT or from this our book of KSG booklet. Whatever suits you, do this. Only one you study. Okay, these are the topics which I am going to discuss. Please stand aside as we cannot see the board. Oh, okay, now it is okay. Okay, fine. Thank you, and have a nice time. Again, I wish you a very nice time. Do study and come. दशहरा सेलिब्रेशन हो गया, दिवाली में पटाखा बढ़ा लिया है ना, अब चलिए with new strength and new level of commitment and dedication. Please work hard, give your best, let us do it, and let's, if you have any problem, anything, let me know that. कुछ भी परेशानी है, समझ में नहीं आता है, बोलिए. You can call me if required, even not now, after 9:30. Okay, it is not possible now. I have a class again. So I request you all, if you have anything, any issues, please let me know that. Okay, and please do study. Again, I am requesting to study and come. These topics I am going to discuss tomorrow. See these things and do. Thank you very much. Have a nice time. Bye bye. Bye. Thank you.